So the next topic is proper motor sizing. So it was a myth that the oversized motors, especially those who are operating below 50% of the load, are not efficient. Okay. So it was just a myth, but the oversized motors or the bulky motors also operate efficiently. In fact, the both the standard motors and the energy efficient motors both have the peaks or the best efficiency at 75% of the full load, and it is relatively down when the load is down or the 50% load point is there. So if we can compare that, the those oversized motors or bulky motors, they are also good enough and they cannot be rejected straight away. In fact, uh, there are some plus points also, that below the 50% load points, the energy efficiency reduces in the energy efficient motors, but they behave quite well. Okay. And next is the adjustable speed drives. So what is this adjustable speed drives? That it is not always that we want to operate at full load, although in few mechanisms or few motors we do not have any controllers, but in few we have. For example, in our mixer juicer grinders we have low, medium, high speeds, and but it is not always the case. Few always operate on a fixed speed, or you can say on the full load speed. For example, our water pumping motors. Okay. In our homes, there are water pumping motors which pump the water from ground floor to second floor, third floor, depending upon the construction which you are having at your home. So that requires the motor of the rating of 1 kilowatt if it is three-story building, or and the tank is above that third story. But if there is a two-story, then the FHP, which means fractional horsepower motors, that is also sufficient. So these motors operate on a fixed speed. We just switch on the supply and it starts rotating and performing the pumping function. Okay. So there is a lot of saving is there when we 2.8 years. Okay. So next is the power correction. So we come across the power factor problem, especially when we are facing the problem of induction motor or inductive loads. So that requires the power correction. So if we install capacitive loads or capacitor banks, then this problem can be resolved. This problem is mainly due to the inductive load. It can be transformers, electric motors, HID, lighting, etc. So power correction is necessary because it reduces our electricity bills, and also the burden on the nation is also reduced. So to better understand this, we know that our power triangle you have studied in the class first year. So the in the power triangle, if you consider a triangle, then the base is the real power and the hypotenuse is the reactive power, apparent power, and the perpendicular is the reactive power. So you can say that the power factor, it is the cos of the angle between the real power and the apparent power. So it is power factor is the ratio of the working power to apparent power, and this working power is also known as real power, true power, etc., which you have already studied in the lower classes. So next is the minimizing voltage unbalances. So we have seen that from the supply end there is a unbalancing of the voltage supply, so which can ill affect the motor terminals also, and especially it affects the three-phase motor and it shortens its life. So there is a, although motors are designed for a particular tolerance, but the continuous variation or voltage imbalances cause problems. Okay. So it will perform less efficiently. Okay. Especially at full load. So what is to be done? The regular monitoring of voltage is done through the thermographic inspectors of motors. Okay. So what is this thermographic inspections of the motors? It is nothing but you can say that hotspot analysis. Okay. So for example, if you are having any device hotspot sensors, so if we are throwing that ray on the motors or on the working parts of those motors, so we can inspect that there is the variation of temperature. If it is too much, then it can cause the unbalance. At higher frequency it is even more problematic. So that is to be checked, and voltage controller is to be installed, and if that is installed, then it is having the payback period of 2.6 years. So again, it is beneficial. Next is the energy efficiency improvement opportunities in the compressed air systems. So while we are studying this compressed air system, we should know that what are its problem areas. So problem areas are the leaking. Okay, so whenever the air is compressed, whether it can be the some hot blower system, if we are in the cold conditions, cold temperature conditions, and some hot blower is there, or you can say hot blower ducting system is there, which is blowing the compressed air, and it is raising the temperature of the room. Or you can say it is the cold blower system or the cold ducting system as we are having in our universities. So the problem areas is their connection points, rubber hose, connection walls, regulators, its seals. Whenever and wherever there is the connection or joints, at the same point there is a problem of, there is likely problem of leakage. Okay, if we are operating for the cold air, so it may leak those cold air. If we are operating for the hot air system, it may leak the hot air system, hot airs. Okay, so again, and also these walls which are made up of irons, it got get rusting problems, leakage problem is there. And aging is also a problem, because our walls sometimes it is rubber walls, and in our rubber walls also, over the period of time, the cracks develop. So the solution to it is that we have to replace those rubber valves. Okay. So it is observed that even 85% of the electrical input to an air compressor is lost as a waste heat. Okay. So leaving only the 15% of the electrical energy which is to be consumed into that compressed air energy. Okay. So we can say that there is a lot of improvement opportunities in this sector. So hmm, uh, because of the relatively expensive operating cost of the compressed air systems, the minimum quantity of the compressed air should be used for the shortest possible time. So, and constantly monitored and reweighed against alternatives. So the next is the maintenance, which I have just discussed, that we have to constantly check for the air leakage pressure system, whether it is taking the pressure or not. Okay, even in our pipe water pumping system which we have at home, sometimes if there is a leakage or a rusting of those pipe, so even if our motor capacity is more, it will, the suction of those, that water is not proper. Okay, so that is to be again monitored, that it and sometimes it is very natural, because the air which is being flown may have different chemicals, and those chemicals affect the surroundings of those pipes. Those pipes can be some hard plastic pipes. Okay, or it can be a metallic pipe, depending upon the situation where it is used. So whatever the case may be, whatever the boundaries may be, but it will affect because of the chemicals which are present in the air. So regular maintenance is required. So so what are the factors which are to be monitored? First is the pressure gauge. The pressure gauges, it identifies the pressure, and it can be installed wherever required on those pipelines, filters. Temperature gauges, it control the temperatures, because if we are having some idea that if we are pumping this much amount of compressed air, this temperature will be raised in this much time. So if that is not fulfilled, then it is to be monitored. Flow meters again, it is used for the monitoring of the air, which is used. Dew point. So dew point temperature gauges are also there. So at 16 degrees, water vapor in the air is in equilibrium with the liquid water, so which is called the dew point. And water vapor is condensating at the same rate at which the liquid water is evaporating. Okay, so that is dew point. The condensation rate is equal to the evaporation rate. At 16 degree centigrade, it happens generally. Next is the kilowatt hour meters, or our energy meters, that is to be also be used for monitoring that whether electricity consumption is in line with the output or not. So next is the reduction of leaks. So we should, if we are constantly monitoring those pressure regulators, condition traps, walls, pipe joints, etc., then we can uh, check its aging, and we can replace that. So that is also very good. And but the problem lies that how to detect the large leaks. Okay, because it may happen that our pipeline is long enough, even in our rooms, if it is used. So if some small leaking is there of air, it is difficult. So the simple way to detect those large leaks is to apply the soapy water to the suspect areas. So if we apply some soap mixed with water, so it helps in the detection. Otherwise we can use the technical ultrasonic acoustic detector. So it can recognize the high frequency hissing sound which is associated with the leaks. So that is the way. Different methods are installed, are used by different sections of the society. So next is the ECDT. The full form of the ECDT is the electronic condensate drain traps. So it is also a reliable device, and it works so that the no air is wasted when the condensate is rejected. Again, its payback period depending upon the amount of the leakage which is reduced, and it is also a good device. Next is the reduction of inlet air temperature. Uh, it can be reduced by the compressor. Okay. For example, again it deals with the temperature which is required. Okay. Sometimes we unnecessarily do the loss of electricity due to not monitoring the temperature or not setting the temperature according to our needs, as in our case in the air conditioners. So that is to be monitored, because every 3-degree reduction in temperature will save 1% compressor energy use. So that will reduce the electricity consumption. Okay. So again, the maximal allowable pressure at dew point is to be monitored. For example, if a particular freezing temperature is given and our we are given some specifications regarding the dew point, so it is to be followed properly. Compressor should be according to the load. It should be not oversized, or because uh, if the pipe size is small and the compressor is size is more, it will also lead to damage of pipes. Okay, because of the pressure which is more. Next is the proper pipe sizing. So again, it is associated with the compressor system, so they should sync with each other. Okay. Next is the heat recovery system. For example, if we are talking of the compressed air system which is at high temperature, so again, if that heat is passed, but if it is not fully utilized, then the exit air which is high in temperature can also be utilized for water heating or any other applications. Next is the adjustable speed drives. So again, for this compressor systems or monitoring, we can use the rotary compressor systems, which can be in which the speed monitoring can be done.